Good morning, good afternoon, and good evening from wherever you are joining us. Thank you for joining us today. Excited to have our partner Fortinet present with us today on easily protecting your Oracle applications with FortiWeb Web. I am Alfonso Aguilera, product manager with the OCI Strategic Partnerships and Marketplace team. So briefly, safe harbor statement for you to read. I'm sure you've come across this, but I wanted to put this up real quick. So I will be covering just a brief intro to what the marketplace is, and then I'm going to hand it off to the Fortinet team to walk through how to easily protect your Oracle applications with Fortinet FortiWeb Cloud. So what is the Oracle Cloud Marketplace? It's a place where Oracle Cloud customers can find third-party solutions to maximize values for their cloud subscription. We have over 2,000 business curated apps ranging from lead gen, which is supported apps, free, BYOL, and paid. And the paid allows your customers to use universal cloud credits to go through those apps. We feature apps built on OCI, just like Fortinet's FortiWeb. And again, focusing on Fortinet, we have a variety of applications that are designed and optimized to run with Oracle applications, which also include FortiWeb. Now, just breezing through quickly before I hand it off to Aiden and the Fortinet team, here are some internal resources for you to outreach. If you have additional questions, we do have a partner page on Oracle.com that reviews Fortinet and all the different services that they provide. So thank you, and now I'm going to hand it off to the Fortinet team.
All right, thanks, Alfonso. Hey, everyone, my name's Aiden Walden. I am with Fortinet, and you should be seeing my screen now. And we're going to dig into how we protect web applications and APIs that you might be deploying on Oracle. So just a little background, Fortinet has been a longtime partner going back to OCI Classic. We originally were providing firewalling services on Oracle Cloud, and we've had a lot of success protecting key use cases that are important to mutual customers, PeopleSoft, e-business suite, and other enterprise applications that you guys are provide to customers. So let's get into it a little bit. So there's a safe harbor statement, just repeating that out of obligation. But what are we talking about today? We're going to talk about FortiWeb web application and API security. This is really an evolution of what you may know or have known as the web application firewall. And the reason that generally the naming convention has changed is because there's different expectations in how we go about protecting services. Firstly, we're focused on API discovery and protection. And this is a dynamic API discovery and protection, but it's a more focused use case than what may have been provided or what was provided by legacy WAFs. What's important for all of you as an audience is that this deploys on Oracle Cloud. We can deploy this in any of your data centers. It can be consumed as either a perpetual license-based service, or we have SaaS versions that can be consumed on demand, if you will. And so, we're delivering capabilities that are specific to the web applications and APIs customers deploy on OCI. And regardless of where those users may be, we can attach to the different Oracle Cloud data centers. We can attach to CDNs. We can even support customers in their own data centers with our SaaS and with our appliances who may be using services such as Cloud at Customer. It could be a specific use case. But all of this is driven by our unique capabilities from FortiGuard and the built-in and syndicated artificial intelligence capabilities. We've been doing artificial intelligence for well over a decade now. We have a global practice where we've put a lot of effort into building up this global platform that can provide threat intelligence in a very fast manner from the millions of endpoints and the billions of signals we get on a daily basis. So the TI, the threat intelligence, is really a driving enabler behind all of our products, and especially FortiWeb FortiWeb. And this FortiWeb is also part of our overall fabric ecosystem approach. So the Fortinet Security Fabric is a mesh approach where, regardless of what vector you're protecting in the IT estate, no matter where those assets and those resources may exist in the cloud or the data center, you can coordinate the protection. You can syndicate threat intelligence that's locally generated within the customer environment to all points in the infrastructure, because everything is tightly integrated, and we can manage the security posture centrally and elevate the overall security posture no matter where we happen to see threats, and we can do that in real time. It also provides the ability, the security fabric that is, to integrate with the underlying SDN of OCI, so farming the OCI infrastructure for information about customers' workloads that may come and go, users that are active in the environment, and then dynamically placing that into a policy framework to remove the manual workflows that typically bog down the security practice and the operator. So I talk about FortiGuard, and it's really important to drive this point home, but FortiGuard, our FortiGuard AI services, drive the capabilities of our entire product set. So whether it's web filtering for egress use cases to protect against DNS-based threats, geographically based threats, or protecting IT and OT converged environments that may be attached to a cloud environment, as we see this overall convergence between these domains as cloud pushes into the edge. We are very focused on that particular type of use case. But looking at this from really three pillars, we focus on the network, the platform, the SDN in the context of OCI, and then the application layer. So we're talking about application layer protections today, but all of this is really to make a more effective SOC and NOC experience. So we're really a full threat landscape security provider, addressing really the pantheon of threat vectors a customer may face. So with respect to web applications are still, the OWASP threats that I think many people are familiar with are still a primary vector. Through our own FortiGuard services, we generate the global threat landscape reports on a regular basis, but we can see the types of threats that are coming through, and they're consistent. Web threats and SQL injections, cross-site scripting attacks continue to dominate. And so this is an area that customers have to continue to focus. And these threats are evolving. And so the challenge for us as security ISV providers and partnering with Oracle is that we have to keep up with these polymorphic threats that continue to evolve. And customers struggle to do that in real time because they have so many unique applications that they're deploying. They're deploying their applications and iterating them very quickly within your own environment. Enterprises have hundreds of applications that are customized in their environment and on their clouds. And so when you look at the total number of software pushes that they may have in their CI/CD workflow at any given day, it's just too much for the security practice to keep up with. So when we start talking about how to protect applications, we have to consider these workflows and how to automate those workflows wherever possible. And that's where FortiWeb really brings a lot of value. So FortiWeb, what does it do from a security perspective? Well, it does a lot of things. We focus on very specific use cases to highlight. Obviously, web application security. So if you have web apps, HTTP applications that need protection, the OS top 10 type protections, we take an organized approach based on using pattern recognition and signatures, We look at things like mitigating application layer DDoS attacks and so forth, and then going into more advanced threats. Security compliance, or excuse me, regulatory compliance. So if you think about, attesting to things like PCI as an example, bot defense, bots are on the rise. We see a lot of automated attacks from bot networks and command and control services that are controlling those bot networks. And the types of bots can be classified, and there are a large variety of them. So it's just not, bot protection isn't just a simple defensive solution. It's something that has to be, you have to understand the different types of attacks that come with the different types of bot techniques. API protection I mentioned, but when you look at these ERPs, original ERPs were confined within the four walls of the corporate environment. They've been opened up to the internet because of the work from home trends and distributed access, work from anywhere really. And so now these systems are publicly facing. And also you have a number of partners that connect through extranet interfaces, as an example. And then all of this has to be managed in an easy way to enable the SOC. Looking a little bit more detail into web application security. So I mentioned OWASP threats, but what we're bringing to the table that's different from other OWASP top 10 protections is that we're applying things like anomaly detection to protect against not just known attacks, but the attacks that may be a zero-day threat that haven't been seen before. We're applying things like IP reputation, sandboxing files that may be coming into an HR system, scanning data flows for malware patterns, and other techniques such as credential stuffing or other authentication attacks. One key point that I don't want to pass up is the opportunity to remove false positives. And this is going to be a differentiator between FortiWeb and its advanced capabilities versus what you may know from legacy WAFs, right? This whole concept of driving automation is really about auto tuning. So this is what ML more than anything provides, is a system that can cut down on the false positives and really tune the system to understand the types of connections that should be allowed, understand what types of requests are maybe anomalous but still benign versus the anomalies that are definitely malicious. On the bot defense side, we want to block bots that are not, while at the same time not blocking legitimate users. There are a lot of different bot attacks. There are biometric bots that can simulate user interactions with the web UI. Those can be more difficult to block. We've gotten very good at that. And so being able to differentiate from what is a bot and what is a human takes a lot of advanced analytics. We've applied machine learning to this and gotten very good at it. But we want to reduce the reliance on user verification techniques that really tend to annoy people, like CAPTCHA as an example. Right, and we apply a number of mitigation techniques. So IP reputation of the originating sender of the session or the connection. We have signatures that look for patterns of data flows, certain thresholds, how many connections per second, as an example, if they're trying to open up a number of sessions. And we look at, again, that biometric interaction. We're looking at keyboard and mouse use and other forms of, human spoofed interaction. And all this is driven by ML again. And the compliance side, we can generate reporting and align to many common standards. So if you have retail customers in your patch that have concern, for example, for PCI, we can protect PII data, and we can ensure that we provide compliance or meet attest to compliance requirements for things such as PCI and other compliance frameworks. This is a big one, protecting APIs. So when you look at, and we'll provide this as part of a little bit of a demonstration today, how we protect APIs, the first thing to do is validate the schema. Is the format of the request, does it meet the schema that's been set for that particular API? We can apply attack signatures, we can apply protocol limits to the API itself. And as we see more and more connections to a particular endpoint, we start to build a profile for that API. And so when we build that profile, we start to have a full layout of the Swagger or the open API file or the documentation for that API. And so we can start to narrow the access to that API by understanding what inputs are expected versus what inputs may be, malicious attempts to access data. SOC operations. This is important because we're going to, this FortiWeb capabilities, that the ones that I've mentioned, are really aimed at reducing the overhead put on the SOC team. The SOC team, when they manage a web application firewall, if you're familiar with WAFs, they spend a lot of time tuning the system, adjusting. If you get 5 updates to an application today, is that 5 times I have to go in and modify the policy for that particular API endpoint or for that particular web app? In many cases, you don't have to do that anymore because the system can respond. You can actually test and provide training to the system such that we know what good connections look like versus what bad connections look like before an application has even been deployed in production. And so this really enables the SOC team to more effectively spend time on malicious activity to detect that quickly. The information that we provide speeds the time to remediate and respond ultimately. Okay, so just a recap, our web application. So we focus on these use cases. There are other use cases, but the takeaways are these. Web application security is focused on OWASP top 10 threats. We're using machine learning across these different use cases to optimize the security operations teams so that they're not spending time tuning the system, that we get rid of false positives. Many of these use case applications have regulatory compliances that we attest to. And 2 particular areas of focus that your customers will have concern for are mitigating against bots, determining whether or not it's a legitimate user making a connection versus a bot that is making a connection, acting very much like a human, and then protecting APIs. And the API protection may, in fact, in the current climate, be the most important, the most important use case on the Oracle Cloud. So with that, I think we're going to go into a demo, and I'm going to hand it to my teammate, Srija Alam. Srija, do you want to go ahead and take over?
Yep. Thank you, Aiden. Let me share my screen.
Okay.
All right. So the way you get access to FortiWeb Cloud is going on to Oracle Marketplace and then subscribing to FortiWeb Cloud. And once you subscribe, you will be creating an account with support.fortinet.com, which will allow you to log into fortiwebcloud.com, where you can onboard your applications. So the first step in order to protect your applications from FortiWeb Cloud is to onboard it. And I'll walk you through the process of onboarding an application here. So we'll just give an application name and the FQDN or the domain name of the application you would like to protect with FortiWeb Cloud. So I have an application within my domain called app.mydomainname.com, and we'll click next. And in the second step, FortiWeb Cloud already checked that the IP address of this domain name, what it's resolving to. If you have more than one IP address, you can already see that it's going to resolve this and give that all of those IP addresses of the instances where your application is being hosted. Now, we need to make sure that FortiWeb Cloud is able to reach that application server on a certain port like HTTP or HTTPS. So we can also customize that. In my case, my application is listening on 8443. So it will need to validate it's able to get to that application server. So once the test comes back successful, we'll move on to the next step. And in this step, we can enable CDN. So if you enable CDN, the data on your origin servers can be cached in FortiWeb Cloud scrubbing centers, which are distributed around the world. So when users will visit your application, they can be redirected to the nearest scrubbing center and render with the requested data, which will reduce latency. So if we enable this, what we are also offering is that you will be asked to select a specific continent or a global, which means your data will be cached in the scrubbing centers within a specific continent or around the world. So we can just see that we could change all of these regions. I'm going to turn this off for this application. So we'll click next. And in this step, in the fourth step, FortiWeb is going to ask if you want to enable the block mode. So what block mode means is that FortiWeb will start blocking the attacks as they are hitting your application, and not only blocking the attacks, it's also going to show in the attack log based on the policies you configure. And the reason we actually give this as an option is that if you don't turn on block mode, it's called the monitor mode. In the monitor mode, FortiWeb will still be seeing the attacks that are going to your application, but it wouldn't take any specific call like blocking, but it would just show the log of this attacks. So as an administrator, we can go tweak the policies if in case we are causing some false positives because of the policies we configured. So we can turn on the block mode. And we are also offering this pre-configured template. So say you have more than one application which belong to same type, like say Tableau applications, you have 5 or 6 and you would like to protect them. You can just create a central template and apply that template to all of the applications you would like to protect. So it's a central collection or a central template, which is a collection of all the policies in order to make a job easy for an administrator. These 6 of them are by default provided by us, but if you would like to create a custom one, you can always do that as well. So I'll just turn this off and click save. And in the last step, in order for FortiWeb to start protecting your application or inspecting the traffic, is to go onto your domain registrar and change the current DNS record, which is the A record you might have for your application, to a CNAME record, so that FortiWeb will inspect the traffic before it gets to your application. So once we change the DNS record, it's going to show OK here. So I have already onboarded an application which is close to a real world scenario. So I have this juice shop application here. And just for an instance, it's called Fortinet Juice Shop. This is available on OWASP project or OWASP website. So this is a retail application similar to retail application where somebody can go in there and order some juice. So there are so many features on FortiWeb Cloud to protect against OWASP top 10 attacks. But in addition to that, we have some machine learning, just like Aidan mentioned, and some API security. So we'll be focusing more this webinar on machine learning and API security. But I would also like to show OWASP top 10 attack or a known attacks which we offer. So the known attacks field is to protect from OWASP top 10 attacks, and they're in different categories which we can protect. We see on the screen that it has SQL injection, cross-site scripting, generic attacks, and many more. So what this is doing is that FortiWeb is bringing these signatures or updating these signatures from FortiGuard Labs. FortiGuard is our threat team organization, which they collect a lot of attacks in the internet, and they use machine learning there as well in order to consolidate into various signatures, consolidate these attacks into signatures, and maintain a database. So this is in constant sync with our FortiGuard labs. So if in case there is a known attack, that's already taken care of for you. So say I want to do a SQL injection attack on my juice shop. So I'm hitting this URL where I have a parameter for search here, which is a Q parameter. So I'm just trying to run a SQL injection attack with this known payload. So if I click here, FortiWeb is going to block that. We see a web page block, and it's also going to give this client IP attack and message ID here. So if we go back onto FortiWeb and see the attack logs, we see that there is known attack, SQL injection, violation, and parameter. That's because it's checking the payload and it's matching the SQLite master from our FortiGuard lab signatures. Now, what about the zero-day attacks, right? Like we might see some zero-day attack parameters that we would like to protect. So we use machine learning to block zero-day threats and other sophisticated attacks. So machine learning will automatically learn about your application, and then it will build a mathematical model in order to protect against this zero-day attacks. So just as an analogy for machine learning, I would say if you flip a coin, you would have two events, right? One is the heads and the tails. So if you flip a coin for 1,000 times, that means you're going to see those heads and tails, but there is a slight chance that the coin might land on the side, very slight chance. So the probability might be very minimal. So that can be counted as an anomaly. So once that anomaly is actually flagged by FortiWeb, because it has learned about this heads and tails even in this machine learning, it's going to take that anomaly, but it's not going to just block it right away. So the first layer, we are using a hidden Markov model, which is the used in the machine learning. And in this, so that's the first stage. But in the second stage, since it doesn't want to just block it as an anomaly in order to prevent false positives, it's going to send to the second layer, where in our second layer, we use pre-built trained threat models to confirm whether it's a real attack or it's just a benign anomaly that should be ignored. So again, that's the FortiGuard labs that's coming into place where the pre-built trained threat models are. So the anomaly is being confirmed. So my anomaly detection model is doing alert and deny. That means I'm going to see a log if I'm caught as an attacker, and also I'll be denied for this attack. So let me do anomaly detection attack through my Postman here. So I'm doing some file inclusion attack here. So if I click send, I'm seeing that it's being logged. This is again a HTML for the web page we have just seen earlier. So if we go back to the attack logs, we could see it's going to pop up in a second, but I have done this earlier, so we could see that it's going to show it as a machine learning anomaly detection, local file inclusion. And if you click the packet details, this is exactly the same payload I have used right now from my Postman. And if we see, it's showing us what the payload it's matching. And not only that, just like I mentioned, the 2 layers of machine learning. In the first layer, it's telling that the sample value is very low of my actual traffic that FortiWeb has learned that's going to the application. But the sample value or the argument value I sent just now is a lot more higher. So it did mark as an anomaly. And in the second step, which this is where we see this pie chart, it's sending to FortiGuard labs, where it's comparing that payload, vectorizing that value and comparing that payload to the pre-built threat models. And the result is that that payload matched the file inclusion attack. So FortiWeb also shows which is the closest attack this zero-day payload or parameter is matching and blocks against this anomaly detections. All right, I just refreshed. So we see that it's the same attack just now what I performed. This is the latest log. So it's everything you could see, it's matching this file inclusion attack. Now, the other unique feature of FortiWeb Cloud, which I would like to share, is for the biometric space detection. So we have seen like, let's take an example of a shopping or a retail bot, because I have a retail application that I have that is being protected by FortiWeb Cloud. So common bot attacks involve like malicious actors that configure bots to automatically place high demand merchandise into carts. So we have seen this in previously in the real world, where a lot of this merchandise are actually bought by the bots and are sold in an marketplace, like a retail marketplace, for much higher value. This has really happened in the past. So the reason attackers do is that they might want to hinder true sales or make money by reselling the product. And then the reason is that bots act faster than humans, so they just do their job faster and buy before we could get into our carts. And in order to protect against them, we usually like leverage any hostile bot detection methods. Like one is the capture challenge. However, capture would leave like a negative impact because it's time consuming, difficult to read, and user would never get it right. Sometimes we would never get it right on the first attempt. So how can we solve this problem is that FortiWeb has this biometric space detection, which you can see on my screen, where it is monitoring for client events like mouse, click, keyboard, and screen touch. So I'm going to just demonstrate that using a small video I've done earlier. So here, FortiWeb is again, if just going through this different events, it's going to monitor on the client side or on the browser, and it's going to collect the events for 10 seconds. We can change that value. So what it is that it's going to check if it, in order to say if it's a bot or not for the first 10 seconds. And then it could do alert and deny, again, the same action. If you see, this is a retail application, again, which I'm trying to click. Trying to order some juice, and this is the bot script we have written. So I'm going to run this bot script, which would actually order some juice, place into the basket, also create an account for this juice shop, and try to place an order for the juice. So it's clicking through those different juice and adding them as we go. And since this user didn't have an account, it's creating an account or registering the account. And as we see that FortiWeb gave a 403 forbidden account. So just to inspect the CSS and make sure it's FortiWeb that's blocking this, if you click that, we see the same attack log or web page that is being blocked. And we see that the bot is also crashed here. Now, if we look at the attack logs, we see that there is bot mitigation, and it's saying it's a biometric space check. And on that URL, because I was checking on all the URLs here, protecting all of my URLs in the juice shop, and that's how biometric space detection is helping. Now, what about the bots that might go undetected, right? Or they might mimic humans, and that has happened. So say if the bots will mimic humans, or if it's directly sending an HTTP request to the application and forge certain fields like referrer, user agent, header, etc., then the biometrics, we need something in addition to the biometric space bot detection. One major things we see in the internet are the scrapers and the crawlers. So for these kind of attacks, we have the AI based machine learning, which FortiWeb has as a feature. So just gonna get this one here. So FortiWeb machine learning ML based bot detection will again learn about the regular traffic that is coming to your application based on the IP and user agent or cookie. You can select between any client and identification method. So it's going to collect 400 samples. 400 samples as in unique user traffic. And there are some actions which we can do, like alert or deny, period block or deny. The alert is again something similar to monitor mode, where you can actually get the just see the attacks there. And once we once we my model is actually running. So in the anomaly in the bot detection phase, there is also a challenge it puts there, which is called like real browser enforcement. So if a bot script is not able to verify the real browser enforcement, then FortiWeb is gonna pass through the second layer, just like we saw in the SVM. And in this phase, it's gonna compare the traffic against 13 different dimensions. We will see that shortly. So this is a scrape product script that is running. So scrapers take a little bit of time in order to scrape that information out of the website. So it will again scan for a bit for a few minutes. And then once it's trying to scrape that data from the web shop, we could see that again, it's a HTML here, which is blocking that request again. And if we go into the attack log, we see that that's a bot detection machine learning. And it's saying that there is a support vector machine, which is our second layer of machine learning. That's the algorithm you're using, and it's a violation there. And just like I mentioned, there are like 13 different dimensions of which this traffic is being compared in the second stage, where, for example, if how many times the HTTP requests are initiated by the user, or whether the request uses illegal HTTP versions, or if it's fetching like JSON, XML resources, etc. So since FortiWeb have already collected samples for my regular traffic, it has put together this average value, maximum value for this traffic. So then it's going to compare that, and once it sees that the sample value is much higher, because bots usually maintain a lot of TCP connections than a user does, or say the HTTP requests are a lot more higher than a regular user does. So since it has put together those maximum, average, and minimum values of my regular traffic, it's comparing that to the sample or this traffic event, and it's blocking that request of the bot, or using machine learning based bot detection. Now, we'll move on to the next feature, which is the APIs, because APIs have been a lot more important to the businesses. So with API protection on FortiWeb Cloud, we have few things what it can do. So first one is the open API validation. Say you have your API in any framework like XML, JSON, or Open API or Swagger. Then you can upload that Swagger onto FortiWeb Cloud. And then just the FortiWeb is going to compare the request that is coming in with the schema which you have uploaded. So I have uploaded the schema for my juice shop. So if we click here, we could see this is a schema for the orders that are being placed, and there are various components in the schema here. So every request that is being coming in is compared against the schema. Say if an order number is not, if it's a string and it's not an integer, then FortiWeb is going to take this certain action. With that said, FortiWeb can also act as an API gateway. So say you have developers who would like to access these applications, and you want to create like a front-end security for authentication. FortiWeb can also act as API gateway, where you can create API keys, and then also say which URLs this API key is expected on, so that it would block that request if it's not seeing that API key. So I created a developer as a user, have this API key here, and I'm just allowing these users. Now, let me just do an attack for the API key, with the API key and without API key. So I've created this a request already, an API call. In here, we don't see that there is any API key, just a regular request. And if we send, we're gonna get that same HTML for the block page. So it's saying that it's being blocked, the client IP, the attack IP address, and everything. So if we do post with orders with the API key, the difference is that if we go onto the headers, I use that API key, which the developer which I've created. Now, if I click a send, then it's going to create that order for me and just giving 200 OK. So if we go back to FortiWeb and then see the log is going to be for the previous one, the first one we did. We can see that it's going to say there is get API key fill. So we'll see that in a second. So there you go. So we see that on the orders URL, there is an API, but there is get API key fill. So since it wasn't present, FortiWeb was not allowing that user to get access to that orders URL. The next thing is that, say you have some shadow APIs which are not documented by the developers, or maybe they exist in the code as endpoints, but they're never exposed out, but the attackers catch them, use them as a attack surface, right? For that, we have machine learning based API protection. In this case as well, it's going to learn about your application. It's going to learn about these URLs that are coming to your application. So once it will reach that sample count, it's going to block those requests by comparing the schema of this API calls from the regular clients. So this is not documented in my open API validation file. There is a endpoint called API users. So it did learn about this URL already. Now, if I see this schema, what it has learned, it's saying that there is a string properties as an username is a string, and then there is a role and all of this information, what it has learned about this API call and the parameters of the data payloads within this API call. So if I go back and do API machine learning, so I'm hitting the same URL, but for my email, I'm just using the pre-request script in Postman, just generating this values here for random number. So instead of, we have seen that the email, the username was a string, but I'm trying to do some random string and random number here, which is much more higher in length of FortiWeb has observed. So if I do that, we see again the same thing. Now we all know that it's going to block this request. If we go back to the attack logs, all right, it timed out. We're going to see that there is API machine learning, and the reason it actually blocked is because the validation for the schema wasn't right. So we see that in a second. Or this is the one which we already have, which I already ran. So if we see again, open API request body violation, because it was expecting a string within certain length, and I exceeded that, or an integer with a certain length, and I exceeded that payload. So it's blocking that request. That's all for the demo. Like I mentioned, we have other features as well, but we just picked these unique features of FortiWeb Cloud. So Aidan, handing off to you.
Thank you, Shrija. Just coming back to my screen here. All right. So hopefully you all can see my screen. And I'm coming back to this concept of machine learning and why it's so valuable, and I think a unique differentiator for our particular product. We've got a lot of domain experience in the machine learning capability, long history, but the benefit is not just to the security operator. When you look at how it's implemented, it really has impact through the whole application lifecycle and back into the CI/CD process. Shrija talked about some of those benefits, but this is where your real ROI comes into play. So think about a developer who is working on an application, pushes it through pipeline, and eventually gets into production. Now, that application in the old way of doing things would have a developer push the code. It would be deployed behind the web application firewall, which would block legitimate requests because it had no awareness of the specific needs of that new code that was pushed. We'd come back to the developer, maybe via a ticket. The developer would have to stop working on what they were doing and then have to go troubleshoot. And then you have a web application firewall administrator who's told, hey, you actually need to tune the firewall. And so they go and start tuning the firewall. Maybe that works the first time through. They spend some time troubleshooting. All of that is repeated over and over again until the user is finally able to enjoy the benefits of the new application. That could be a lot of time. Now, do that for hundreds of applications from a large development team, you know, and iterating that dozens of times a day across those applications. That's thousands or tens of thousands of updates. Obviously, this doesn't work. And this is where legacy systems have been so much of a burden overhead for everybody in the application lifecycle, that WAFs were largely turned off, which opened up a ton of security threats, or you know, just made applications completely vulnerable. And so what we have to do is not do it that way anymore. So what we've done with our machine learning, as Shrija has gone through, is that when a developer pushes code, that code can be understood by FortiWeb. The machine learning, as Shrija said, takes a certain number of samples, starts to model what is expected behavior for a user or access to an application. There's nobody in the middle that has to tune the system. The web app or the application developer continues iterating their applications. Their workload goes down. The end users are happier. So, you know, potentially on the back side, you have happier users who are generating more revenue. On the front side, you have more productive application developers, and the SOC team, which struggles for resources, can scale much better, but your legitimate threats are being blocked. And so we can take that type of capability and make it available as a cloud native solution, right? So we can provide this as a SaaS, as Sri just showed. The SaaS is available to be deployed with filtering clusters, those machine learning capabilities in OCI data centers. So when a customer deploys their application in Oracle Cloud and they onboard the application through FortiWeb or with FortiWeb, the FortiWeb inspection is done in the same data center on OCI as where the customer's application resides. That's massively important because in a differentiator, because we cost optimize, obviously, right? We're not traversing multiple centers, but it's also performance optimized so that the application experience is maintained. We don't reroute through other data centers, our own data center. So massive benefits for everybody in the application experience. Now we have this as a service. This is a sampling of some of the ordering that can be done. Now, right now, Oracle Cloud Marketplace doesn't have the opportunity to build directly through the marketplace itself. So customers are referred back to Fortinet to onboard this. However, why this is important, well, now and into the future, is in the future, you know, we think there may be some ability to purchase this. We would like to see the ability to purchase this directly through Oracle Cloud Marketplace, you know, and have Oracle be the payer of, or the payer of record for the customer, or the payee of record. Sorry, getting them mixed up, but regardless, when a customer is purchasing FortiWeb for an Oracle use case, it removes a ton of it removes a blocker in the sale. You don't have to go back and refactor web security into the deployment of the application. Your sales can close more quickly, and you're working with a customer to factor in security from the beginning. And this is all built around best practices security. And so this is why, you know, we think this is a very strong value proposition to be sold with Oracle Cloud use cases. So we've been asked to compare this against the OCI WAF. There are use cases definitely where the OCI WAF will meet the customer's requirements. We don't want to take that away. There is a natural breakwater where a customer may have additional requirements. And so that's where we see the opportunity to collaborate. So when a customer has multi-tiered web applications with you know, the application delivery processes that are highly dynamic in nature and evolve very quickly, we can bring some of the advanced capabilities to bear. We can apply other capabilities on top. So when we early in the conversation, I talked about our Fortinet security fabric that integrates with other services that it can attach to Oracle Cloud. So sandboxing to detonate malicious content and URLs and test connections to maybe unknown command and control servers. All right. And just to summarize those use cases again, if you have any of these use cases, we'd love to work with you on them to help you close business faster and help your customers realize a secure experience in Oracle Cloud. So if you have web application security in general, any sort of web services where customers need advanced defense against or advanced bot mitigation, API protection, and they're really looking for a way to scale their SOC operations, these are areas where we'll be able to help. And with that, I really want to thank everybody for taking the time. I want to thank the Oracle partner team for allowing us to spend time with you all. We look forward to the opportunity to partner with Oracle on Oracle Cloud initiatives wherever possible. Thank you very much.
Hi, yeah, we can still hear you.
Okay, I just want to make sure it was completely silent, so I didn't know if my audio was coming through. So okay,
yeah, that's all good. Thank you very much for your time today.
Sweating a bit. Okay, thank you guys. I appreciate the chance to do this with you all. Yeah, do it again soon, maybe sometime.
Yeah. Thank you, Aiden. Thank you.
Alfonso.
Good. Thank you very much.
See you all. Take care.